Hello everyone. Good morning, good afternoon, and good evening. I'm happy to be talking to you, and thanks to the organizers of the SiriusCon for giving me opportunity to talk to everybody here. My name is Raman, and I'm an enterprise architect with McKinsey and Company. I'm based out of Bangalore in India. I've been a software developer for more than 20 years now. For the past few years, my area of research has been to find ways to accelerate software development, be it in UI development, middleware, or cloud engineering. AWS Workbench is one of the tools I have developed as part of my research agenda. AWS Workbench aims to minimize the gap between the cloud architects and the cloud developers by providing a design to deploy framework. This tool would not have been possible without the features of Eclipse Series and, more importantly, the OBO designer. I have used almost all the features of Sirius in this tool. Over the next 20 minutes, I propose to explain the motivations behind this tool and also give you a brief demo of the tool and its capabilities. In current days, the way the software development is done, especially the way the cloud architects and the cloud engineers go about doing their jobs, there is a clear disconnect between the way they work. While on one hand, architects use multiple tools like Draw.io, Lucid Charts, PowerPoints, and some of the Eclipse tools also to create the diagrams required for software deployment and the cloud deployment. And on the other hand, the developers use tools like the AWS CDK, Terraform, or the CloudFormation to convert those diagrams into scripts which can then be deployed on the cloud infrastructure, and then that cloud infrastructure gets created, right? But if you see here, what happens is that the diagrams that are created by the cloud architects have to be translated by the cloud engineers, and there is no that there is a lot of problems that there are a lot of problems that could come with that. Let us look at some of these problems. Some of the problems because of this is there is a waterfallish handoff between the architects and the cloud DevOps engineers, which means that there is one architects complete the work before, and then that's the output of the architects is taken up by the cloud DevOps engineers, and there is no iteration or there is no not much of communication between these two actors. Then there is an absence of what you see is what is deployed view of our infrastructure, which means that it's quite possible that the way the architect describes the cloud infrastructure is not exactly the way the cloud engineers would be able to interpret it and create the infrastructure that's required for the solution. And similarly, there are ad hoc and obscure changes to infrastructure, right? So sometimes it's quite possible that the architect changes something which is not communicated to the DevOps engineers because there is no workflow between the static infrastructure diagrams that the architect creates and what the cloud DevOps engineer generates as the infrastructure. So that is a clear gap there. And for me as a infrastructure manager, I would have a lot of trouble in getting that singular view of the cloud inventory, right? I wouldn't be able to rely on what the architect has showing as a diagrams or what the cloud engineers show as infrastructure, and there is this mismatch over there. And because of this waterfallish handoffs, there is this decreased agility between in the whole process. Now, because of that, there are some symptoms that we have seen in the past, and of course, I am sure even you would have experienced that in your respective jobs. The cloud architect, often I have heard the person say, the deployment diagram is old, haven't found time to update it, but the real infrastructure is something that's different. Or the product teams say that we could not find anything that will match our requirements, or we could have used the same, because there is this mismatch between what the architect has designed and what exists on the infrastructure. Also, we have seen that the cloud engineer could go ahead, because of the pressure of the delivery and so on, go ahead and make changes to the infrastructure without really informing the architect, right? So all that is possible. And then there are the infosec guys, the information security guys. They uh, after a certain system is in place and is in motion, that there is this resistance, because of this singular view to find out what to change, and if something changes, how would it affect the other systems, right? And finally, anybody new joining the team, or coming or being new to the organization or new to the team, they would have a tough time getting a view of what's existing and where to get started, right? So looking at all of these problems, we need tools, and I think it's high time that we need the tools that we can use uh, to alleviate some of these problems. And these tools that we need should enable the best practices and patterns based development, which means to say that the way you design a certain system is the way you should get it deployed. And when you design the system, it should adhere to some of the best practices, and those best practices should be enforced by the system in which you design, and not come as a quality input from the designer. Of course, the designer needs to be competent, but the system should be able to do the checks and balances, and see that the best practices are adhered to. There should be ways to enable the design level verification, because once we are looking at a design as a tool which will direct how the infrastructure is developed, and not as two disconnected parts. And that's why there should be a way that we are able to do the design level verification, and that is why we need tools like Sirius and OVO Designer, where we can enforce these constraints on the designer so that the things are done right the first time. There should be avenues for accelerated communication between the architects and the cloud DevOps, right? If there is a change that is required in the infrastructure, the cloud DevOps should not be able to unilaterally make this change, but something that needs to get communicated back to the architect, so that the design and the infrastructure are in sync. There should be better traceability and stakeholder communication for deployed infrastructure. Often, the infrastructure managers rely on multiple people to get that singular view, and especially in large enterprises, this view is often broken. And of course, once you have a designer-based environment, there is a lot more opportunity for reusability and management. Yeah. So for all of this, that's why there is this term called ArchOps, which is a designed to deploy kind of infrastructure, which means that we all have heard about DevOps, where we are kind of bridging the gap between the developers and the ops people. But now we need to extend that further to the architects and the architecture guys, which makes the process seamless across the architecture, the development, and the deployment. So no longer the diagrams are isolated from the devs process, but they are well integrated into the dev process. And this ArchOps is an idea in software development automation continuum whose time has come. So in future, we would increasingly see that people want to minimize that communication barriers between architects, between developers, and the ops guys. Right? So on basis of that, and took an inspiration from these problems that I have seen in past few years, that I designed this cloud workbench. The cloud workbench was developed keeping these goals in mind, and it is built using Eclipse Series and AWS CDK. The Eclipse Series, we all know, is a wonderful tool uh, which accelerates the development of the designer environments. And I have been amazed at the features provided by OBO Designer in particular, the way I can describe the models, the way I can describe features, properties, and all the visual elements like drag and drop uh, and identifying each elements and then drill downs and so on. Along with Sirius, I also use AWS CDK, which is a developer environment for developing infrastructure as code. And then once you develop this code, it gets deployed on the AWS accounts. So how does the Cloud Workbench help? So what we have done using Sirius is given the architect a canvas on which the architect can drag and drop various cloud infrastructure elements, be it say an API gateway or a network load balancer, ECS clusters, or the databases. Then once this canvas is ready, and once the cloud infrastructure is designed using OBO Designer, what we can do is you can generate the code, and then the code gets generated in AWS CDK format, and this AWS CDK supports Node, JavaScript, TypeScript, Python, and Java. So currently, I am using Java as the language in which the canvas or the designer generates the output in. Now, this code is deployment ready, which means that I can use this code and compile it using Maven tools, and then directly deploy it to the AWS accounts. Which means now what we have done here is that we have removed the gap or the translation effort between we have removed the translation effort between the architect and the cloud DevOps engineer. So there is this one environment in which the architect designs the AWS infrastructure, clicks generate code, and then the code is ready. And so this code can then be augmented by DevOps engineer if required, otherwise can be directly deployed to AWS infrastructure. So anytime now that some changes are required, the architect can incorporate that in the designer itself and redeploy the infrastructure. So what that means is that the view of the infrastructure is initially created, and which is true to the deployed infrastructure on the backend. And that kind of tool doesn't exist yet. We have tools where you can design the environment, but then the development of the infrastructure is altogether a different task. So Cloud Workbench provides, of course, first the state-of-the-art designer, which we don't see anywhere else, and this has been possible due to the features of Eclipse Series and OBO Designer. And then from there, it also then translates that into Java code and this Java code that is generated adheres to the AWS best practices, and it is patterns-based development, which means that, like I told before, the design level verification is already in place and the checks and balances are in place because of the patterns. Otherwise, the generated code won't compile at all. And one of the big features is that, because of this generated code, the cloud DevOps engineer, we save about 80% of the time for them to, which they spend to developing the code, right? So that's um, all about the motivations and for me to create such a tool. And again, thanks to the OBO designer and the AWS CDK kind of tools, that this project was possible. Um, Next, I would like to spend some time showing you the tool, the way it operates, and then we can, I'm happy to take some questions. Thank you. Hello, welcome to this demo of the AWS Workbench. What you see here is first the way I have developed the model, the edit, and the editor. Uh, One of the main tasks for developing the AWS Workbench had been to first convert the AWS jar files, which have all the classes and the properties of defining the AWS infrastructure, into an eCore model. For that, I have used eCore model extraction tool, which reads the Java files and then generates the appropriate eCore models. Now, in that, some of the tasks were that, I had to weed out some of the classes which were not important for generating the resources. And so what you see here on the right hand side are the list of classes that I had converted into eCore models, and these are about 200 services of AWS cloud infrastructure, which I have converted into an eCore model. Now, these are the models that I have then used for generating my workbench design. If you see the workbench design here, the nodes that you see here are closely aligned to the resources that are available in AWS. So the general structure of the diagram is that there is a main app. An app contains one or more stacks. Now, stack is a AWS way of defining a group of resources. Now, each stack can contain one or more blocks. Now, blocks is a more of a visual representation for the OBO designer, for us to group some of the cloud resources together, so that some of these resources can be individually addressed and individually developed and then combined into forming a full stack. A block can contain all of these AWS resources. You can see all the resources that you saw in the previous edit project as the nodes in AWS Workbench design. Now, each block can also contain sub-blocks, so that you can drill down into blocks and give a logical grouping to your resources. I will quickly jump to the demo of one such design I have already created for this talk. This is how the designer looks for AWS Workbench. What you see here is first the stack, and the stack has multiple blocks, right? And inside each block, there are AWS resources. Now, if I click on one of the resources, what you can see here are the properties for that resource. So the properties could contain what is the variable name of the resource, what are the identifiers, and some of the other properties which define the behavior of each of these resources. Now, these properties are what I have gathered from the AWS jar files and the Java class files, so that for the user, end user, or the architect, the architect does not need to know what are the exact methods and properties. They are all listed down here. Of course, the architect needs to know how the AWS infrastructure is set up for them to understand what do each of these properties mean. But apart from that, they don't have to do any hand coding of these properties while they generate the code. Now, similarly, if I click on some other properties, suppose I am clicking on the API gateway, then the API gateway's properties come out here. One of the other features that I have done, so where are all those properties now? So if I click on one of these blocks, I have done a drill down so that your main diagram doesn't get cluttered, and you have a bigger canvas to work on your AWS or configuring your AWS resources. And here on the right hand side, you can see all these properties, all the resources that you have at your disposal to define your cloud infrastructure. Now you can see some of the arrows here. These arrows determine what is the dependency of the cloud one resource to the other resource, which means to say that the cloud API gateway is dependent on the sample REST API object here. Similarly, if I go to some other property here, say let me expand this particular block, and in this block what you can see is there is a virtual private cloud VPC that I have defined, and this virtual private cloud has two subnets, one in US region 1A and another in US region 1B. Now if I want to create a dependency, so if you are aware of the cloud infrastructure, you would know that the subnet is dependent on the VPC. So for that, if I want to create that kind of a dependency, I can easily easily create it using the connect dependencies edge connection. I click on one and then connect it to the VPC here. See, so now when I click on the sub US 1A, you can see that the that particular subnet depends on the default VPC, and this is how we can create dependencies. Now these dependencies are important for us to detect the cyclic dependency and what resource needs to be created before the other one. So this is the way we can easily go about creating the infrastructure diagram, and this is what the architects would use. Now you can see that some of the each of this block also has a property called can deploy. Now what happens is that if some of the, now let me expand this load. So here I have added a note that this is not yet deployed, means that this is still in a draft stage, and the architect still needs to work a bit on organizing the resources that needs to be deployed to the infrastructure. Now once the architect has made all the changes, they can just click the can deploy button here and save the object. So what happens is now this also gets converted into code. Now how does it get converted into code? Here is how we converted this into code. So what you'll see here is when I go to the main diagram, which has all the blocks, the sub blocks, and the resources defined, I can go and say generate code. When I do a generate code, what happens is another project gets created, which is appends a code in front of the parent project, and here I can see that the code is already generated, and this code is in Java, and none of this has been hand coded. All of this is coming from the diagram that you have defined. So if you can see here, the main stack, the property of the main stack is main stack demo, and the description is demo stack, and so on. So if I have to change that, let us look at the properties of it. So here I can say, and I can add edited here. If I do that and then I save this and I do a generate code again, you can see that whatever changes I have made on the diagram in the properties gets reflected in the code. So absolutely no coding required. And once we have generated this code, there are also the helper classes, and the helper classes are something that the cloud engineers might want to use for adding additional properties. So there is the main class, which is the ArchOps demo, which is injected into this helper class, and you can add more variations for your cloud infrastructure over here without affecting your diagram and the generated code. Now, once the code is generated, what we can do is go to the command line, and here is where my entire code is. You can see the code structure here. The same code structure is reflected here, and I do a simple mvn compile. The code gets compiled without any errors. And once you have the code compiled, you do a CDK synth, which synthesizes the entire infrastructure into a CloudFormation template. Yeah, you can see the CloudFormation template here, and let me open the way this gets the Java code that we wrote or which got generated gets transpiled into the CloudFormation template, and the CloudFormation template is what we can deploy directly to AWS account, and your required infrastructure will be killed and will be created. Yeah. So if you see here, there's about the CloudFormation template, the number of lines are about 1,300 for the and let us also look at the code that we had generated is about 89 lines of code. So these 89 lines of code, CDK code, it gets translated into about 1,300 lines of CloudFormation code. So for me as an architect, I don't even have to write this Java code, and I can directly create everything as a diagram. And of course, for each component that I create, I provide the properties, and then rest of the stuff is magic. So I have here, if you can see, I have leveraged all the features of OBO Designer, be it creating canvas, creating connections, and then also auto generation of code from there. Thank you for listening.
How many time have you spent to build this environment?
So I started this in about August last year, and then I took till January to get my first version out. So yeah, it's totally mine. I mean, like I was the only person who was developing it, because the idea before I need some validation before I could ask for put it out and get more people to get engaged into it. So yeah, it took 5 months for me to get the first version out.
Okay, thanks. And Cedric is asking, could you please repeat how you did create the eCore model and from what?
So the eCore model, there were a lot of the Java CDK, AWS CDK is available as source code, and so I looked at the source code, and then there is this one program, one open source project called as eCore model extraction, which converts the Java source files into eCore models. So that's what I used. But over and above that, I had to write a lot of filters to remove all the unwanted classes, and then I generated the eCore model using that. Yes.